So today let us do the introduction of the machine learning. This is your lecture one. I'm Dr. Pankaj Agarwal at IMS Engineering College. Now, as we all know that human beings are pretty good at solving the problems by learning the things. We can learn from examples. We can train ourselves based on given examples, and once that learning is done and once that training is complete, then we can apply that learning to the solving different problems. Now, that is what the machine learning the objective of machine learning is all about. We wanted to put, or we want to build that kind of ability that what human beings have in solving the problems into machines. So, machine learning basically aims at it's a basically a field of computer science, which, with the help of which, we want that computer system get a sense of data in similar the same manner what human do, right? In the same manner, what human can perceive a problem, in the same manner, what human beings can learn and then solve a problem. Uh, we human beings are also good at solving a problem when some kind of inputs are given. We are able to identify some kind of patterns out of that input. We can although we doesn't know about the output, we doesn't know how we have to classify our inputs, but still we are able to find some kind of similarity between our input, and then we can even when we have not learned about it. So so there are two different aspects of learning which human does in majority of the cases. Like, one is a supervised learning, where we have a set of examples, where we have historical data based on which we learn the things, and then we may apply that learning to some new learnings to classify new kind of inputs. There could be another kind of learning that we are very good at, that is your unsupervised learning, where we have your input, we does not know and how that input has to be dealt with. We does not know what is the output classes that we have to put our inputs, but still, based on our previous learning, or based on something that we have learned in a different domain, we're able to identify some kind of relationships between our present learning, and then we can apply that limited learning to identify and classify the inputs which are given to us, even when we are not trained for that. So these two aspects of learning of human beings is what is the objective of machine learning as a technique. We wanted to put this kind of learning into our machines, that is supervised learning and unsupervised learning, and that is what is the overall objective of your machine learning as an technique, or as a systematic approach is. So machine learning is basically what domain of artificial intelligence that extracts the pattern out of your data by using the algorithms, or machine learning algorithms that we would be talking about. Now, the overall goal of your machine learning is to build computer systems where we can put in this kind of intelligence, and that can adapt and learn from the experience. When we say adapt, it means that whatever learning I have, or whatever learning that I have achieved, that learning is never fixed in nature. We keep on incrementing that learning. The more input comes in, we keep on updating that learning, right? So that learning is always in on adaptive nature. It is not kind of static kind of learning. It is always a dynamic mode of learning. So that is what the objective of the machine learning algorithm should be, right? And we also learn from experiences, right? Put these two kind of aspects into a machines. That is what the overall goal of machine learning algorithm says. Now, this machine learning concept is not at all a new concept. It is pretty old concept. In fact, it dates back to 1959 by Sam Arthur Samuel, when defined the this machine learning as a field of study that gives computers the ability to learn without being explicitly programmed. That means what? Say, when we say that we have to program a machine, so when we program a machine, so it needs a set of instructions, right? And the machine is going to behave exactly in the same manner on the basis of whatever instructions that have been given to that program, or to that system, right? So and that defines the static behavior of your machine. So we want that machine should that the system should learn automatically with the environment, that should learn automatically with the inputs that are being given to it, and it should automatically develop those algorithms. So we'll be talking about what exactly we mean by this specific statement when we say that we do not have to do explicit program, right? So let us first understand basic concept over here to distinguish between what is the basic difference between your traditional programming approach and your machine learning approach. Now, as you can see over here is what we have done is, in traditional programming language, you see that there are two basic inputs, right? One is input on the base of which we would be making some decisions. And definitely we all know that by the von Neumann architecture, this input needs to be a correct input, right? And then we have a set of program, right? The instructions that we know. So we give instruction by using some programming language, by writing a program. So based on these two things, we apply this on a traditional machine. We get an output which is expectedly right, or correct output, with the condition that input and the program should be correct. That is what we are known to play with, right? Now, when it comes to machine learning as a science, you can see a basic difference over here. Input is, yes, it would remain same. It would problem specific input, right? And over here, along with this input, we would give output, right? Output, that is, what is the expected output corresponding to each input, right? So, and at times, this output is not there could be cases where we only give input, the output also not given, right? So when we would be talking about supervised learning, so we would be only giving the inputs, and when we would be we would be giving both inputs and outputs. And we would be talking about when the unsupervised learning, then we would be only providing the inputs, the output would be missing. So in and all, we have inputs and we have outputs given to your machine learning. Now, this machine learning would act as a black box. And the most important thing is that this input, X is the input and Y is the output. I does not know that how I can go from input to the output. In the previous case, in traditional programming, I knew that process. I knew that process via a program. I knew that process via a set of instructions, by a set of algorithm, right? But over here, I does not know any relationship between what relationship exists between your input and output. And that is where we started talking about some different technology or different scheme. Because had we would have some kind of understanding, had we would be knowing that how I can go from input to the output, then I could have written a well-defined algorithm for it, and then a traditional programming approach would have been good enough, right? Since we does not know for majority of real life problems that how I can go from how input to output, how it can be reached, does not know the procedure. For example, weather forecasting problem, like in weather forecasting, I does not know the algorithm that if some input comes in, then how whether I can apply some algorithm and can predict the future forecasting. That cannot be done. There is no well-defined algorithm, there's no well-defined scheme over it, right? So what we have in machine learning algorithm, we can have input, we can have output, and then we have to somehow devise a relationship between input and output based on in the same manner the human does. That is what happens with humans most of the time in the learning case. We does not do the procedure, but still with the kind of complicated structures that we have, we are able to undefine, we are able to devise some kind of function. That function basically does what? That function basically maps your input to the output. And but any means we does not know how that mapping has been done. So mathematically in machine learning also, we actually target at this function, right? So it mathematically what we are saying that we given a set of inputs, given a set of outputs, let us devise a function. Let us devise a function such that once this input would be given, so what we can do is once this input can be given, we can produce the output. Now, this mapping between your building this function, that is developing this mapping between your input and output, basically is done by human beings in the form of training, right? We give enough examples. We have number of examples in terms of x and y, and by using those examples, we try to understand. We try to build up a function f, right, without knowing the actual procedure out of it, and then once that function is developed with sufficient number of input and output pairs, then what we can do, we can say that our training is complete, or in simple way our learning is complete. Say for example, we can do is we can give some kind of new inputs. Now this input can be given, what, some new inputs can be tried, and the same function can be applied, and then expectedly if our learning is good, then we can produce what, correct outputs. So that is the overall funda of overall mechanism of machine learning algorithm is by doing this function approximation. So machine learning is all about nothing mathematically, it is a function approximation scheme. We approximate this function, and this approximation depends upon the suitable number of examples, the same way what human does. If the suitable number of examples, if the number of examples of the number of training pairs, we call it, if that is good enough, then the possibility of developing a good function increases. And then once a function is becomes perfect or it gets trained, then we can use that same function to apply it on some new inputs, and then expectedly we should get what, output, right? So this machine learning, if we want to like summarize that, what do you mean by learning a function? So machine learning can be summarized as what, that we have a function that maps your input to your output variable, right? And this is y is equal to fx, and the algorithm learns this target mapping function from what, your training data, isn't it, that we were talking about. And the form of the function is definitely unknown. Mind you, this form of function, what would be the form of function, because we does not know that how this function would be calculated, right? We can assume some kind of assumptions about this function, as we would be talking about this in the form of parametric and non-parametric functions, but we does not know that how function can be mapped. So our task is what, as a machine learning algorithmist, is to evaluate the different machine learning algorithms, and that is where so many schemes exist. So we does not know which of the function would fit well to my data. So actually it is a fitment through a function. So we have to try different machine learning algorithms which can fit to my inputs and output well enough, so that I can develop a good function. So different algorithms will have its own complexities, will have its own suitability or own fitment over the data that is input and the corresponding output. And would be the case when we does not even know about the output, we only have what, input, in case of unsupervised learning algorithms, which we would be talking. So in that case, with the output also would be missing. So the only part that would go to the algorithms or to the machine learning algorithm is your inputs. So finding some kind of interesting patterns or relationships among inputs. So that is what has to be done while doing some kind of classification or doing some kind of application on your inputs. So different will make what, different assumptions or the biases about the form of the function and how it can be learned. So that is what the different algorithms may. So at times it may happen that a given algorithm may be more fitter or finds a more fitment to a given data, and other time some other algorithm may find a more fitment to the other kind of data. So what algorithms would fit to your data, that you have to try by applying various machine learning algorithms. So there's one term which often confuses students. That is what is machine learning and what is data mining. Are these two terms interrelated or correlated or are different? What? So mind you, this data mining as such, it actually refers to your extracting the knowledge from the large amount of data, right? And the overall goal of a data miner is basically to find some interesting patterns in your data. For example, in cricket match, if you must have heard in your commentaries, like whenever Sachin Tendulkar plays or scores with a specific amount of average or scores 50 in your first 50 over, then the chances of winning by India increases by 80% to 90% whatsoever. So this kind of interesting pattern, or interesting kind of pattern, is not something which is put into your data. You cannot find that kind of information in your data. That has to be extracted from your data, and this data can be huge. So that is what the data miners have to do, right? They look for the patterns, they look for interestingness into your data, right? So they are not concerned with the algorithm that we are applying. Whereas the machine learning basically is you have to make your hand dirty on it. So machine learning is to discover the new algorithm from experiences. They talks about developing that function. They talks about what function would be more fitter to your data, right? So machine learning basically becomes a kind of prerequisite for data miners, because every data miner would be applying some or the other kind of machine learning algorithm in order to find some interesting patterns, right? So machine learning algorithmist would be only concerned with the fitment. It would be more mathematically associated with what function would be mathematically more fitted to your data, right? And the data miner would be at a kind of level where they would be talking more in terms of whether the data or whether the extracted information or the knowledge would be useful or not, right? So machine learning involves the study of algorithms that can extract the information automatically, right? So it is at the implementation level actually. Now, let us first try to understand the entire process of your machine learning process, right? So, the most important thing for applying any kind of machine learning problem to your machine learning algorithm to your problem, that you have to define your problem. You must have a clear understanding of your problem. You must know that what is your objectives, your inputs are defined, how your outputs are defined, and what kind of mapping you want and what you're looking for. What is the representation of inputs, what is the representation of your outputs, right? So this is what is the definition of the problem, is the first step that we all know. Now the second important step is your collection of data. Like we have to collect the data on which we can apply this machine learning algorithm. Now in the collection of data, there can be different aspects. For example, as I was talking about that machine learning, in most of the cases, in the case of supervised learning, so we have to apply the training part, right? And for doing the training, we have to have a set of known pairs of input and output. That means we need some kind of historical data. So to apply some kind of machine algorithms, if it does not know anything about that how to proceed, if it does not know anything about that function, so what we can do is, for example, in case of weather forecasting, so in weather forecasting we can have amount of data from the previous past, and so by working on this data we can develop that function. So while collecting the data, one of the aspects of collecting the data could be gathering the data from the past, where we collect both input and output pairs, right? Similarly, it may happen that we does not have any kind of data from the past. For example, in a class, suppose it does not have any previous records of the students, right? And suppose still I want to predict that what would be the performance of my students. So what I can do is I can ask my faculty members to kind of scale the students' performance, to scale how the students behaves and performs in the classroom learning on a scale of 0 to 5. So there the data comes from the expert, right? So definitely the past data is also can be thought of as the data from the experts, but I'm talking of data from the experts where we does not have a past data. Similarly, once collected your data, right? The mere collection of data may not be good enough, right? So the data may be suffering from huge number of problems. We also call this feature engineering, right? So like huge problems in the sense what? The data may have a lot of duplicacy. That data may not have complete data. It may have missing values. That data might be noisy. That a lot of problems. That data may be only a partial truth. So there can be a lot of issues with that data. So you need to clean your data, because if you're going to produce, if you're going to apply some kind of corrupted data which has a lot of issues, that is, which has a lot of inconsistencies into the data, then it would definitely affect your the algorithm. So it is suggested that you should always clean your data first before giving it to your algorithm. So cleaning of data is one of the important aspects while preparing the data. And similarly, that could be the case like we have to format the data according to the requirements of the algorithms. my algorithm may be more suited to a tabular form of data. So we need to convert it into, for example, into Excel format. We need to convert it into a database format, or we need to convert it into a CSV format. So formatting the data as per the requirements of the algorithm, or as per some other requirements, or converting it into a suitable form, is also one of the important aspects of your ML process. At times, like, our data can be very huge. For example, I have suppose 5 lakh records, and handling that amount of data at such a huge level may definitely affect the performance of my algorithms. So the easy out way is, like, we can have a sample, we can collect a sample out of the entire database, and this sample has to be very carefully selected in such a way that the all kind of possible variations and the representations of the input are present in that particular sampling. And then we can take a sample, we can apply the machine learning algorithm on the sample, and whatever result comes, we can say that that result is also applicable to my entire population, or to my entire records. So this is also done, and this is nothing new. It is a very old statistical way out, right? So similarly, we can have a process called decomposition. For example, I can have a field called information called address, and suppose this address is in the form of a field where the name, where the city, where the address, and different aspects are all associated into a single field. So we need to decompose it. We need to find the name. We need to separate out the name. We need to separate out the flight number. We need to separate out the city. We need to separate out the pin code. So what we are doing is a kind of decomposition. So at times we need to decompose our data also, so that it becomes more suitable for applying the algorithm. And at times we also need to do the scaling. In fact, most of the time, for example, I can have two features. For example, I have a feature called, say, age, and I have a feature called, suppose, basic salary or salary. So, like, which would be in the limit of, suppose, 0 to, say, 100, for example, yeah, 10 to 100, right? And suppose and the salary can in the range of, suppose, 50,000 onwards. So the magnitude of the values, both the values, differs a lot, right? So magnitude of these values can, and once we would start applying the algorithms, any kind of algorithm, statistically, then statistically what would happen, that the bigger values will have a more significant role, or the algorithm would be more biased towards these bigger values, or these high magnitude values, so which is not required, because for me both the fields, or both the features, would be equally important. So in this case, what we do is we scale the inputs. We often normalize these inputs so that they come into the same scale, right? So the magnitude of the values is, in machine learning algorithms, is not considered to be of huge significance. Now, once we are done this process, now we have to decide, like, once we have cleaned the process, then we prepare your data. Then what we need to do is we have to divide your data into your training and the testing sets, right? So what you mean by training is, like, even like when, for example, I have been given, suppose, I have to appear for a test tomorrow, suppose, right? So and I have, suppose, given have been given a set of questions to learn. So I have what a training pair. I have your inputs and I have your outputs. So I have your questions, set of questions, I have set of answers, associated answers. So what I would be doing before the exam is your training, right? I would be training myself. I would be learning. So from the inputs, that is from the answers, from the questions, I would be learning your answers, right? So this training would be in process, right? The next day, when I would be going for a test, right, I need to do that would be your test, right? So test means what? In that test, I would be only given the inputs, the output would not be given, right? So that whether I have learned properly or not, it is the test which is going to evaluate my performance, right? So definitely, if suppose I have been given, or if I have learned 10 questions, and if I have been given, out of those 10 questions, I have been given one of the answers, and then definitely in that case, the probability or the possibility of performing well would be quite good, right? And that would not be the correct form of evaluating my performance. Performance would be evaluated only when, suppose, if I have learned 10 questions and if I have been given some questions which was not learned. So that is, and if I am able to answer those questions, that would be the the real test of my performance. So similarly, in machine learning also, we have a training set, some different training set, and we have a different testing set. So once a training is done, we set a function f. Once that training is complete, so we say that we have learned that function, right? That is what we were talking about. So once we have learned this function f, we say that a training is complete. So this function is complete, right? That's where we're talking about. And then once this training is complete, then when we are going to test this function, then what we do is we apply the new inputs. We apply all those new inputs which were not part of the training, because if the same set of examples would have been given, then it could have been the case that my function would have learned or would have memorized all the inputs. So that would not be the real performance test. So the testing and the training data is always different. We though have the training data has to be more in the ratio of 70 to 30, 80 to 20. These are very common kind of the ratio that we have. So training samples have to be good enough so that function can be approximated well enough, right? And then we can test with a small data in order to what training has been done is correct or not, right? So the training and testing data would be completely different, so that the performance can be evaluated in a nicer way. Now, once you have decided with your training and testing, then we have to do a kind of algorithm selection. Which of the algorithm would be good or not, right? So that requires a lot of expert inputs, or that requires a lot of kind of experience. With the experience, you learn that which kind of algorithms. There are some set of algorithms which, according to literature, which are good at doing specific kind of tasks. Some, like for example, some algorithms would be good at doing a regression kind of work. Some of the algorithms would be good for supervised kind of learning. Some of the algorithms would be good for unsupervised kind of learning. So there are some kind of literature and the parameter information that we can always study, and then we can accordingly apply the algorithm. But still, it's difficult always to say that which of the specific algorithms would perform better in every case. So algorithm selections also requires some kind of efforts, right? So and once this algorithms is selected, then we start applying my training data to my algorithm, right? Then we evaluate my algorithm on your testing data in order to understand that whether this algorithm is performing well or not. And then we can also do some kind of parameter tuning, right? Before declaring that my answer is correct. So by evaluating my testing data, I can evaluate the parameters in case something is not working properly. Then we can evaluate those parameters, we can tune those parameters, and then we can again apply the training vectors, and then the testing can be redone so that the performance of the algorithm improves further. And then we can start utilizing that model to newer set of data. We can start using that model means what? Model means that we have developed that function, right? So whenever we say that we have developed a model in whatever case, so we actually have developed the function f. So we can start applying this function to new set of inputs, and then we are expected to get correct outputs, or near to the correct outputs, right? And that is what the entire strategy of machine learning is all about. Now, as we have already told, like this training, validation, and testing. So we need a training data. That training data has to be different, right? We also can have a validation data. Validation data again, so we can entirely divide our data. For example, I have 100 records. For example, 100 tests, 100 training pairs. So I can have out of that 70 can be dedicated, or 60 can be dedicated to my training part. I can have 10 data for my validation part. I can have again rest of my data for testing part, right? So validation basically does not involve in the learning. So once the training is complete, function is built, we do a validation without actually we're not doing the testing. We validate whether those parameters are correctly working or not, whether the model is behaving correctly or not. So validation basically it provides an unbiased kind of evaluation of your fitment of the model on the training data, while the tuning parameters are adjusted, right? The model occasionally see we normally do not see this validation data set, right? But most most of the time we are only okay with your test data. So rest we will be doing on the next session, where would be start continuing it further. Right, thank you for this session.